variables, explain the difference between correlation and causation. All right, so we're going to start with number 1, draw and interpret a scatter plot. What is a scatter plot? So we're going to see the kinds of scatter plot we have first of all. So let's see scatter plots first. This is a scatter plot. We want to see a lot of them. Well, this is a scatter plot. If I draw a line here, the line has passes through the points, but all the points are not on the line. The x-axis is called the explanatory variable or predictor variable. Y-axis is called the response variable. All right, so I will say that's a high positive linear relationship. Right here, there's a high positive linear relationship between the predictor variable, the x-axis, and the response variable, which is the y-axis. If I draw a line of best fit in this scatter plot here, you will have a negative slope. Therefore, if I'm told to describe the scatter plot, I will say that's a high negative linear relationship. High negative linear relationship. Linear, remember it is a linear regression. So high negative linear relationship between the explanatory variable and the response variable. Okay, let's go back down and see more scatter plots. Well, this scatter plot does not show a linear equation. This is actually quadratic. So we said there is no linear relationship because what we are doing now is linear relationship. There is no linear relationship here. It looks like it's a cubic polynomial. So there's no linear relationship. There is no linear relationship here because I cannot, if you look at this scatter diagram, has no direction. Has no direction, there's no linear relationship. Okay. Positively related or associated and negatively associated. All right. So the parameter for correlation coefficient is called rho, P, rho. This is a Greek rho. All right. The the statistic is R. All right, we shall be talking about R all the time. So let's talk about the properties of coefficient of correlation. Okay, so the linear coefficient of correlation coefficient, which is R, you can say it is between -1 and 1. In other words, R can be equal to -1, and whenever it is a -1, we say perfect negative linear relationship. If R is equal to 1, we shall say perfect positive linear relationship. And by the way, this is R. We shall call it small r. Call it small r. So this small r is R like a statistic. If it is capital, we call it rho. Greek word rho. Spearman's correlation coefficient. Okay, so we know whenever we say that's a perfect positive linear relationship, it means that R is equal to 1. Perfect negative linear relationship are equal to -1. Okay, so we are looking at properties of correlation coefficient R. What are the properties of correlation coefficient? That's what we're looking at now. Okay. If R is close to 0, we say there is no linear relationship. We just looked at that. So look at this one. There's a perfect positive linear relationship. All the points are on the line. So that's perfect positive. Perfect positive. In this one, all the points are not on the line. So you can say strong positive relationship or high positive relationship. You can choose high or strong. Well, I can also say moderate here, moderate positive linear relationship. All the points are not on the line, and the line of best fit is a positive slope, has a positive slope. On the one here, we say there's a perfect negative linear relationship. Perfect negative linear relationship. Okay, right here, there is a strong negative linear relationship because all the points are not on the line, and the line of best fit has a negative slope. Same thing here, moderate and negative linear relationship. This one has no relationship. No relationship because it's scattered. There's no relationship here. It looks like it is quadratic again. Okay. Okay, so we're going to do an example. So let's do an example of linear relationship, linear correlation. So this is the depth at which drilling begins. This is the time to drill. So the depth here is 35. Time to drill 35 is this is in feet, and this is 5.88. So we're going to put it in our calculator. So and then I'm going to get my calculator. Turn my calculator on. Put this data in my calculator. Okay, so I'm going to go to Stat. I have data in L1 and L2, and I still need them, so I'm going to do L3 and L4 this time. So the first data I should enter is the predictor variable, which is the predictor variable, which is the x-axis, okay, or the explanatory variable. The first one is 35, so 35, enter. 50, enter. 75, 95, 120, 130, 145, 155. Okay, but that's not all of them, so we have to go down and keep entering them. We still have more of them. Okay, so the next one is 160. So 160, enter. 175, 185, enter. 190, enter. So that tells me that there are 12 of them. Okay, so the next one is go to my L4 and enter the response variable. I'm going to go to L4 and enter the response variable. So L4. Okay, and then I'm going to arrow up and enter the response variable. So I'm arrowing up to enter the response variable. All right, so getting that. Starting from the first one, the first response variable is 5.88, 5.88. Second is 5.99, 6.74, 6.1, 7.47, 6.93, 6.42, 7.97, And then the next one is 7.92, 7.92, 7.62, 7.62, 7.89, I mean 6.89, and 7.9. Okay, so I see that the sample size is 12 also for the response variable. Okay, the next one is to graph the scatter plot. So let's graph the scatter plot of this data. Second start plot. So now I'm select plot 1, and in plot 1 I see scatter plot. That's what I want to do. One of the types of statistical plot is scatter plot, and it's the first one. So I'm doing a scatter plot. I'll arrow down, and it's asking me, where is your L1? Where is your response variable? Predictor variable is in L1. My response variable is in L2. Okay, the predictor is X independent variable. The response is Y. So they are good where they're supposed to be. So I can now zoom 9. Zoom 9. Whenever I try to zoom 9 and this argument comes up, I'll do second quit. And then zoom 9 on the main screen. Zoom statistics. Okay, so what I'm going to do actually right now, I'm going to take that equation out. Okay, zoom 9 again, zoom 9. So the scatter plot I have right here, is it what I'm supposed to have? Yeah, well, let me see. Let me see. I need to go back and see if I fixed something right. So, okay, I did not. So I'm going to go to second start plot again and make sure I tell my calculator that my data is in L3 and L4. Sorry about that. L3 and L4. I can't forget that. So second L3, second L4. Second L3 and second L4. Because if I don't, it will just graph what is in L1 and L2. And that's what it did for me now. So second L3 and then second L4. I'm sorry. So the scatter plot will be L3 and L4 because my predictor variable is in L3, response variable is in L4. Now, when I zoom 9, I will have a different scatter plot. So zoom 9. So this argument is here again, second quit. Then I'll zoom 9. So I see I have scattered plots that are scattered everywhere. Even though it is scattered everywhere, I can actually eyeball it and see that the line of best fit is going to the right. So the line of best fit is going to the right. Okay. So what I'm going to do now is write down that there is a high positive linear relationship between the predictor variable and response variable because of the scatter plot. I already know there's a high positive linear relationship between the predictor variable and response variable. But they also want me to find the coefficient of correlation. So to find the coefficient of correlation, I'll go to Stat, arrow to Calc, and do a linear regression. Number 4 is linear regression. But also number 8 is linear regression too. See, number 8 is linear regression. But in number 8, you see that in number 8, the slope is B. In number 4, slope is A. I like to use A because it looks like the slope intercept form we learned in algebra 1. So I'm going to use number 4. And my calculator is asking me, where is your predictor variable. Predictor is in L3, so I can't forget that. Predictor is in L3, response is in L4, second L4. All right, and then it's going to ask me now, do I have frequency? No, I don't have frequency. Now it's asking me, do you want to store your regression equation in Y1? Yes, I want to store the regression equation. It doesn't have to be Y1 though. I want to store the regression equation on Y1. So vars, Y vars, function Y1, and then I'll go to calculate. So I'm calculating the regression equation. It's going to give me the equation. It's going to give me the slope. If it doesn't give me the coefficient of correlation, I'll go and turn on diagnostic. Okay, so I'm going to turn, so it gave me coefficient of correlation. But what if it did not give me the coefficient of correlation and coefficient of determination? If it did not give it to me, I'll go to second catalog and look for diagnostic on, turn it on. So anytime I calculate the coefficient of correlation and it doesn't give me R and R squared, I have to turn diagnostic on. So if I hit enter, I get diagnostic. If I turn it on, then it's turned on. So I have what I need. So let me zoom 9 again, zoom 9. And the line, I asked my calculator that the line should be in Y1, the equation should be in Y1. And if I eyeball Y1, I see that equation is in Y1. Okay, so that is the equation here. All right. But anyway, I'm going to clear this and make sure I'm going to do it twice. That way so I want us to see that we just put the data in L1 and L2, L3 and L4. The equation is in L3 and L4. So if I do scatter plot, before I do scatter plot, I want to clear Y1. Okay. So if I zoom 9, I get the scatter plot. Then I can explain that there is a high positive or moderate positive linear relationship between X and Y. Then the next thing is to put a line on the scatter plot. How do I do that? I go to Stat, arrow to Calc, select number 4. You can choose number 8. I like to choose number 4. And then the X list, which is the predictor, is in L3. The response is in L4. I don't have frequency list because I'm doing linear regression. My calculator is asking me, do you want to store your regression equation? Yes. I want you to watch me again how to tell my calculator. This is how to tell my calculator to store the equation in Y1. Vars, Y vars, function Y1. Vars, Y vars, function Y1. Then I'll calculate. All right, so this is everything I need is here. The kind of equation I'm drawing is the slope-intercept form with the slope equal to 0.012. The y-intercept is 5.527. The coefficient of determination, r squared, is 0.597. The coefficient of correlation is 0.773. Okay, I can actually write this in. Now I can put this down in my, write everything that I am given. Okay, so I will put them here. Let me get my, I'm going to get my y equals. So this time I have my whiteboard. So I'm cleaning my whiteboard so that I can okay. Now, the next thing is write down all my calculator give me. So it gave me the y that I used is ax plus b slope-intercept form, where a is 0.012. So I'm going to rewrite this equation and write 0.012 x, and the y-intercept is 5.527. 527. The coefficient of determination r squared is 0.597. 0.597. The coefficient of correlation is 0.773. Okay, so I have that, and if I pull my calculator up again, I can actually tell my calculator, I can actually zoom 9 again, zoom 9, and it comes out with the same. Then I can push trace and arrow down so I can see the same equation here. So now I have the regression equation, I have the scatter plot, I have the equation, I have the regression coefficient of correlation, I have the coefficient of determination. All right, they can ask me, is this, can I prove that there is a linear relationship between R and between X and Y, predictor and response variable? When they ask me this question, it means something. I really have to go and check out the correlation coefficient. So I'll arrow down and look at the table provided for me. This is the table here. And the sample size is 12. So I'm going to look for 12. So the sample size is 12. Well, the sample size is 12. I have 0.576. But my coefficient of correlation is greater than 0.576. Therefore, linear relationship fits the model. That is linear relationship between the two variables, x and y. Even the table, okay, even the table proves it also.